Fine.
Maybe like it melts easier, like it lowers the melting point.
It melts easier, yeah.
The freezing point increases, because if it decreases, it would take longer for the salt to actually get through to melt the ice.
Okay, so you're saying the freezing point increases?
Yeah.
Okay, so think about that when we're talking about the salt that you put on the sidewalk. Do you want the temperature of the water to freeze at a higher temperature, like closer to 100, or a lower temperature closer to 0?
Closer to 100. Am I wrong?
Well, let's think about this. Do you want ice to be on the sidewalk?
No.
No. So if it's cold out, if it's like 25 degrees, normally water would freeze, right, to make ice. But if you put salt down, usually, you know, if it's not that cold out, the water is not gonna freeze as easily, right? So it's 25 degrees out, the water is gonna melt, right? It's not gonna freeze. So do you think the freezing point is lower than 32 or higher than 32?
Higher.
I think it's
So Pat said higher, some people think lower. How about the rest of you? Who thinks higher?
Wait, can you repeat the melt?
Yeah.
It's a do not.
Because the freezing
Do you think it's,
I was going to the opposite of what you
is it lower the freezing point or raise the freezing point?
Lower.
It lowers it.
Oh,
It lowers the freezing point, right?
lower.
So it makes it more difficult to freeze. So does that make sense? We'll check back on that later. Because you don't on the sidewalks you don't want there to be ice, right? So if you're adding salt, it lowers the freezing point, right? So kind of think about that as we go through the lab, because we're going to be using ice, we're going to be using salt for our experiment. Okay, so you should have done the reading of the article last night. And we're going to find out real quick. So let's do a little review from yesterday. We were talking about the changes that occur when you add salt to water and when you add baking soda to water. So what happened yesterday in your activity when you added salt to the water? What happened to the temperature?
It stayed the same. I was like, it didn't.
Okay, yours stayed the same. What about you, Gina? What happened to your groups? Got lower? Okay. Anyone else? Do you not remember what happened? Was it that long ago?
It says salt or?
Yeah, salt. So you did salt and baking soda in separate beakers.
How we did calcium?
Calcium chloride is salt. So there's table salt, and then there's what's called a rock salt.
Oh.
So rock salt is what goes on the sidewalk. That's the calcium chloride. What's table salt made of?
Sodium.
That's sodium chloride,
Oh,
right?
okay. Alright. For ours, it's just it didn't move. It stayed the same.
Yours stayed the same.
Yeah.
What about for the baking soda?
It went down.
Okay, so we got some different results.
I don't know. Is it supposed to get lower? Or is it supposed to get higher? That might affect my answer.
The calcium.
Well, your results should determine your answer.
The results say got higher, but my eyes was a little foggy yesterday from the pollen and all that.
Caroline, what happened with yours?
I'm sorry.
Which one?
For either.
So baking soda is lower, like the temperature is lower, and for the salt is getting higher.
Okay. What about yours, Isaac? T.
Oh, mine stayed the same.
Stay the same.
Yeah.
Jamie?
For the baking soda, it lowered, but for the salt, it raised.
Okay, so people got different results. How do you think? Why do you think that might be?
Temperature.
Okay, maybe you had different amounts.
I don't think it's recording anymore.
Oh dear. Okay. Why else? Remember, so this is like brainstorming now possible sources of error. Why we might have gotten different results.
Maybe you didn't dry the thermometer. Like you put it in one, and then you didn't
Yeah, we'll probably need
Or
another.
you just put another one, and it didn't move.
Wait, say it one more time.
If you put the thermometer in one cup and you didn't like dry it off the thing, and the next cup like what? Maybe that had something to do with it.
Mm-hmm. So it could have been something with your
Probably
thermometer. Right?
One of the, like the thing we were using to weigh, like there was nothing on it and it was still jumping up into like the like 0.20s. So maybe like we didn't put enough because.
Okay, could have been inaccuracy with the scale.
Maybe you got the
You know?
timing wrong with the temperature, like when you go through like 10 seconds instead of.
Okay, that could have maybe slightly affected. Pat?
You can have enough of salt or baking soda.
Maybe there wasn't enough. What else with the thermometer though? What else could have, besides maybe not rinsing it like somebody said? Emily?
You like couldn't, when you have thermometer like tilting, it might not be the accurately.
That might affect your temperature a little bit, not having it straight up and down in the center. Maybe if it wasn't fully submerged by the water that it was in. What else with the thermometer might have affected the result? Stephanie?
Like before you put the thermometer in, like it was at a different temperature.
That could have been, yeah. Maybe you were holding at the end, which would have changed the temperature. Maybe it was stored in a place that had a different starting temperature, so that could have affected it. What else with the thermometer? No one said this one that I'm thinking of yet. You know? Could have read it incorrectly. Maybe you counted the wrong way.
Human error.
That could have been possible misreading.
Probably broken.
Yeah, could also be broken. I mean, that's definitely possible. So, the results you should have gotten were the same as Caroline, and I think Emily or Jamie also said when you add baking soda, it lowers the temperature, and then when you add calcium chloride, it raises the temperature of the water. So that kind of leads back into what we were talking about yesterday with endothermic and exothermic reactions, and that directly applies to our lab. So what are the Demela? What are the three states of matter?
You know like when it's frozen, like the melting points, isn't it?
Just in general, the three phases, three states of matter.
Liquid,
Liquid,
there's
gas, and
frozen.
solid, right? So what's a change from solid to liquid called? So we said it before. Melting. Liquid to gas,
Evaporation.
evaporation. How about gas to liquid? What's that called?
Condensation.
Condensation. And then liquid to solid?
Freezing point.
Yeah, freezing. So we have a chart up here that describes those changes. So you guys got it right. If you're moving in this direction from solid to gas, those are endothermic changes. If we're moving from gas to the left all the way to solid, so gas to liquid, liquid to solid, those are exothermic. Do you agree or disagree?
Endothermic means you're giving off.
Remember what we said yesterday? What's endothermic?
Inside.
What about inside?
It takes heat.
taking
Oh.
in,
Takes heat in.
And it'll
Mhm.
give out cool air, and if it's giving out cool air, if it's taking cool air, it'll give out heat. Yeah,
So the endothermic takes in heat.
and then gives out cool air.
Exothermic
Gives out heat.
releases heat, right?
they're supposed to be flip-flop.
So do you? Sorry, let's look at this. You tell me.
Giving it heat.
Do you think going from solid to liquid, liquid to gas,
It's wrong, it's wrong.
evaporation,
Yeah, the other
is
way.
this
That's right.
endothermic?
Yeah.
It's excellent.
Cause when you're bringing heat in, it melts.
Excellent.
It's like if you go from
Yeah.
solid and you bring heat in, that makes it liquid, so melting.
So are you saying this is correct or not
I'm
correct?
saying that's correct, yeah.
So we got one correct, one not correct.
No, we're not changing it, it's correct.
Why is it correct, Isaac?
You know, because, it goes from solid to.
But when you boil something, like liquid changes to gas. You know, you've seen a pot of water boil, and you see the
Wait a minute, it's wrong. I'll tell you why.
steam come off, right? And you see the bubbles, and it looks very hot. You know, if you've ever touched steam accidentally, you know it's very hot, right? So is that exothermic or endothermic?
It's wrong. Cause the arrow says like solid to liquid, and that's not solid. Is it melting? Not, never mind. It's right. That's it. I'm done.
So I'm not talking about this melting. We're talking about, is this endothermic?
Yes.
What do you think, Natalia? Natalia, is this endothermic going from
See that position.
solid to liquid, liquid to gas? Or is that exothermic? So Emily actually got it correct. She said you have to put heat in to the liquid in order for it to melt, right? You need to put in energy. But Lila, when you go from liquid to solid, why is that exothermic?
Because we're giving off heat.
How? How is heat given off when something is frozen?
Oh wait, never mind. Cause it's, wait, what is exothermic mean?
You tell me. We just said it together. Somebody want to help her out? Gina? Exothermic gives off heat. So how does this make sense, liquid becoming solid?